So today we're going to take a look at our adding and subtracting of fractions. That's our next step. The first thing that you need to make sure that you have is a common denominator. Anytime you go to add or subtract fractions, you need to have a common denominator. Once you have those common denominators, adding and subtracting them is really easy. All you have to do is combine the numerators of the fractions together. You just combine the tops. You don't have to change the common denominator when that happens. So if we look at these two examples that we have here, for the 3/5 and the 8/5, they both have a common denominator of 5. So when we add them together, we're just going to add up the 3 plus the 8 together to get 11, and we don't change the denominator of 5. It stays a 5 the whole time. Same thing in the next example that's already written out. We have 5 over 2x and an 8 over 2x. Those are already common denominators. So what we're going to do is just combine the numerators. 5 take away 8 would be -3. And that common denominator is going to stay a 2x when you actually combine the two fractions together. So once you find the common denominator, you're going to keep it. Okay, so here's the main thing: simplifying by adding or subtracting. The first step that you're going to do is to identify if you've got a common denominator already. Okay, if there is a common denominator, then all you need to do is some adding and subtracting. The thing to watch out for is any distribution. When you subtract the second fraction, you subtract the entire numerator. So in this example here, I have a 3x. Well, I'll first check your denominator. So we've got x plus 3 in both denominators. Those are the exact same denominator. The first fraction has 3x in the top. The second fraction has 5x minus 14. When I subtract, I have to subtract all of those terms. Each one of those terms is being subtracted. So my new fraction might look something a little bit like this. The 3x is going to subtract with 5x plus 14. And that's going to be all over my common denominator of x plus 3. So this subtraction sign will have to distribute to both the 5x and the 14. So I'm going to distribute that negative sign to the 5x and the 14. This is what we're going to end up with: 3x minus 5x minus 14 all over that x plus 3 common denominator. From there, we are going to combine some like terms. We have that 3x and that negative 5x. Those are like terms, so we're going to add those together. We're going to end up with negative 2x plus minus 14 all over x plus 3. Your two fractions are subtracted. So what's the other possibility? The other possibility is that you don't have a common denominator when you start off. If you don't have a common denominator, you need to make one. The way you make common denominators is by multiplying. You will only be multiplying. Sometimes it's one fraction, sometimes it's both fractions. Sometimes you'll multiply by just a number. Sometimes you'll just have to multiply by a variable. Sometimes you're going to have to multiply by an entire expression, something like x plus 3. But you are always multiplying to get the common denominator together. So in these examples down here, we're going to just take a look at what we're going to have to do to get the denominators to be the same. In this first example, we have a denominator of 4 and a denominator of x. Obviously, those are different. So what we're going to do is we're just going to say, what would I need to do to get those two denominators to be the same? What would I multiply by? So since that first fraction does not have any x's in it at all, we're going to have to multiply by an x. So in the first one, I'm going to multiply the top and the bottom of the fraction by an x. In the second fraction, I don't have any 4's in my denominator at all. So it means I'm going to have to multiply by a 4. So I'm going to multiply top by a 4 and the bottom by a 4. So what does this look like? The first fraction changes into 3x over 4x. The second fraction changes into 8 over 4x. Now, I know it's tempting to try to simplify right now, but remember, our goal is to add these fractions together, and we haven't done that yet. So we are going to add the fractions together. 3x plus 8 all over 4x. It's all one fraction. I've combined all my like terms if I can, and I'm going to stop there. I've got a plus sign in this numerator now, and that's going to stop me from doing any canceling. So that means this is my added fraction, the final sum. In the next example, again, we have two denominators that don't have any addition or subtraction signs in them. We have a 5x and a 7x squared. We have to think about what would we multiply by? What do we need to multiply by to get those to be the same? Start with your numbers. The numbers are 5 and 7. How would I get 5 and 7 to be the same number? They can both change into a 35. So that means I will have to multiply the first fraction by a 7, and the second fraction will have to multiply by a 5. Now, if you notice, they both have x's in them, but they don't have the same number of x's. The 7x squared has an x times an x. It's got two of them in there. So that means we need to make sure that there's two x's in the first fraction as well, an x squared. So we're going to make sure we also multiply not only by a 7, but by an x. Let's take a look at what this looks like when we multiply. 7 times x times 4 will be 28x. On the bottom, 7 times 5 is your 35, and your x times x is x squared. In the second fraction, 3 times 5 is 15, and we have a 35x squared in the denominator. We now have those common denominators that we're looking for. It's already there for us. So our answer is going to have a 35x squared in it as our denominator. The numerator is going to be combining those two fractions together. The first one's 28x, and we're subtracting 15. Those are not like terms, so we're just going to write them out. 28x minus 15. And there's your simplified fraction, your difference. The last one's a little different because we have a plus sign in the denominator. Once that plus sign is in there, these two denominators are very, very different from each other. One of them's x plus 1 and the other one's x. I cannot just add an x, or excuse me, I can't just add a 1 into that second fraction to make these the same. I know that would make it look the same, but we can only get common denominators by multiplying by something. And there's not a way I can take x and multiply it by something to have it to change into x plus 1. So this is a situation where both fractions are going to need to change, and they're going to multiply by the other denominator, kind of like what we did in the very first example. This means this first fraction is going to have to multiply by an x on the top and the bottom. The second fraction is going to have to multiply by x plus 1. First fraction is going to look like a 3x squared over x times x plus 1. Your second fraction is going to look like a 2x plus a 2 all over an x times an x plus 1. So we did a little bit of distributing up on the numerator. I didn't do any distributing on the denominator. I want to try to keep the denominator as simple as possible, so I'm going to leave it in all those different pieces. There's an x piece, there's an x plus 1 piece. I'm going to leave those pieces in the denominator. The numerator, though, what I want to try to do is combine like terms if I can. So it's really important to distribute 2 times x and 2 times 1 to get that 2x plus 2 numerator. Last thing I'm going to do is combine the two fractions together. My common denominator is x times x plus 1. And I'm going to look for any like terms in the numerator. I've got a 3x squared added with a 2x and a 2. None of those are like terms, so we're just going to write them all out. And there's your fraction. So what are we trying to do here? You're trying to add fractions together, you're trying to subtract fractions together. You are going to be done with your problem when you have an answer that is one fraction that has that common denominator in it. So you have to actually combine those two fractions together. You don't want to do any canceling or anything like that. You just want to try to combine fractions together. You're going to be done when your answer has a numerator that is simplified. So when you've distributed things, when you've combined like terms, if that top pieces all come together and everything's combined as much as it possibly can, that's when your answer is going to be done. Sometimes you can check to see if your top can factor again. So for example, in that last problem that we did, we had 3x squared plus 2x plus 2. That's a trinomial. That's one of those PS2 problems. We could see that maybe it might be able to be factored. In this case, it can't be. But we would always want to check to see if that's possible. So we can check for factoring, and we can check to see if we can cancel some things. It won't always happen. You're not going to have to do that for every single one of these adding and subtracting problems. So those are some of the things that you're going to look for to make sure that you're actually done. You're trying to add two fractions or subtract two fractions together. These are the checklist things that you want to look for. So here's just a few examples of some fractions that you would consider to be done. In this first one, you've got a 2x, and then you happen to have two pieces of your common denominator. I'm not going to distribute that common denominator at all. So I've got one thing in the top and like maybe two factors in the bottom. That would be an okay final answer. Something like this here in the second one, 3x plus 4 over 4x, that is as far as that one can go. There's no canceling that can happen there. You've got all one fraction. All the like terms are combined. In the next one, we happen to have a quadratic on the top and then just one common denominator basically on the bottom. That's okay too. That would be an example of something that cannot be canceled. You can't do any more factoring. You're done with that one. It's also possible in some of these problems you might just end up with a numerical answer, just a number on the top and the number on the bottom. That's unlikely, but it is possible that if you're going to cancel some things out at the end, if you're allowed to, you might end up just with some numbers.